So picture this. In a single 12-month window, we're talking the year 2026, 10 different nations walk up to roughly 30% of the Earth's critical mineral supply, and they just completely lock the vault.
Just boom. Done.
Right. Done. No more raw dirt leaving the continent. And today, we are taking a really deep dive into the massive paradigm-shifting geopolitical earthquake that happened right after that.
Yeah, and I mean, it is arguably the most aggressive and really the most coordinated structural realignment of global supply chains that we've seen in the entire 21st century.
That's huge.
It's massive. We are watching the complete rewriting of how technology is sourced, how it's built, and ultimately who controls it.
Exactly. Which brings us to the mission of today's deep dive. We've got this massive stack of recent geopolitical reports, financial analyses, tech sector announcements, all from this pivotal year of 2026.
Right. A lot of source material to get through.
Tons of it. And our goal is to really unpack this transition because we are watching Africa pivot away from this centuries-old dynamic of just being the world's quarry.
Yeah. Yeah, just a place where raw materials are extracted and shipped off.
Right. And instead, transitioning into an active, self-determined architect of the global digital and semiconductor ecosystems.
And what's really crucial to understand here, and you see this across all the reports, is that this goes way beyond just, rocks in the ground.
Right.
The central theme emerging from these 2026 texts is this concept called hardware autonomy. African nations are basically leveraging their immense geological wealth to build permanent technological sovereignty.
So it's not just holding the ingredients anymore.
Exactly. It is a strategic pivot from possessing the ingredients to owning the entire kitchen.
I love that analogy.
Yeah.
And, for you listening, why does any of this actually matter to you? Whether you're following global trade, or maybe you're investing in the green energy transition, or you're just trying to figure out where the next big leap in AI is going to come from.
Which everyone is right now.
Right. Exactly. This shift is going to fundamentally alter the devices in your pocket and the massive data centers powering your whole digital life. So let's get right into the foundation of all of this.
The literal foundation.
Yeah. Before we can talk about microchips and algorithms, we have to talk about the dirt.
We really do. And to understand the shockwaves of 2026, we have to look at what analysts in these reports refer to as the lopsided supply chain.
The lopsided supply chain, okay.
Right. It's an economic dynamic that's deeply tied to what economists historically called the curse of riches. So to put it in perspective, the African continent holds about 30% of the globe's critical mineral reserves.
Which is a staggering amount.
It is. We are talking about the lithium, the cobalt, the rare earths, the exact elemental building blocks that you need for literally everything from EV batteries to, advanced military electronics.
30% of the world's supply. I mean, that is massive leverage. But the paradox in the historical data here is just, it's crazy.
Yeah, it's pretty stark.
The reports note that despite holding a third of those materials, the continent historically captured less than 1% of the total economic value of the technologies those minerals eventually enabled.
Exactly. And that is the absolute core of the lopsided supply chain. Like, a country might export a ton of raw, unprocessed ore for, a few $100s.
Right.
That ore is put on a ship, sent across the ocean, refined into specialized chemicals, then it's manufactured into a battery cell, packaged into a consumer device.
And then sold back.
Yes. Sold back to the global market and often to the very country that mined the ore in the first place for tens of thousands of dollars.
Wow.
So the overwhelming majority of the economic value, the high margin intellectual property, the job creation, all of that happens thousands of miles away from the mine shaft.
It's essentially like subsidizing the industrialization of the rest of the world.
That's a great way to put it.
You're basically handing over the foundational ingredient at wholesale prices, and then paying a massive premium for the labor and ingenuity that someone else applied to it, like selling someone your wheat for pennies and then buying back a loaf of bread for $10.
Exactly. Which brings us to the cascade of export bans in 2025 and 2026. This was a synchronized rejection of that exact dynamic.
So where did it start?
Well, Zimbabwe fired one of the early warning shots. They suspended all exports of raw minerals and base lithium concentrates. You couldn't just, dig up spodumene rock and put it on a boat anymore.
You had to actually do something with it first.
Right. You had to at least process it into battery-grade lithium carbonate locally.
It wasn't just lithium, right? Because looking at the stack of reports here, it lists this crazy domino effect across the whole continent.
Oh, absolutely.
The Democratic Republic of Congo shifted from a blanket raw cobalt ban to imposing these extremely strict annual quotas, Ghana put a hard deadline on the calendar, announcing they plan to halt all unprocessed ore exports entirely by 2030.
Which is a very aggressive timeline.
Super aggressive. Kenya implemented an immediate ban on raw gold, copper, iron, and rare earth elements. And then you see Senegal, Malawi, and Mozambique following suit with their own massive regulatory overhauls.
And when you aggregate all those policy shifts together, you see that currently 16% of the total global trade in critical minerals is suddenly bottlenecked by these new local processing restrictions.
16%. That's a huge chunk of the global market.
Yeah, the tap hasn't been turned completely off, but a massive filter has been installed.
Okay, hold on, though. Let me play devil's advocate here for a second, because looking at the historical precedents in our source material, this strategy, well, it doesn't always work out perfectly.
No, it definitely carries risks.
Right. Like, look at Indonesia. A few years ago, they succeeded brilliantly with a nickel export ban. They basically told the world, hey, if you want our nickel, you have to build the stainless steel and battery refineries right here.
And it worked amazingly well for them. Their export values skyrocketed from roughly $3 billion to $19 billion in just a few years.
Exactly.
Yeah.
But when they tried the exact same playbook with bauxite, which is the ore used for aluminum, it largely stalled out.
Right.
The global buyers just shrugged and went to buy bauxite from Australia or Guinea instead.
So aren't some of these African nations playing a really dangerous game here? I mean, won't global buyers just reroute their supply chains to South America or Australia if the rules get too strict?
That is the multi-billion-dollar question. And the geopolitical analysts in these reports spend a lot of time digging into this exact nuance.
Because it's a huge gamble.
It is. And the reality is that leverage is not distributed equally across the geological board at all. It really comes down to market concentration.
Okay, break that down for us.
So take the Democratic Republic of Congo. The DRC controls roughly 70% of the known global cobalt reserves.
70%.
Yeah. So if you are a major automotive manufacturer and you're committing to an entirely electric fleet by 2035, you require cobalt for the thermal stability of your batteries.
Otherwise, the cars catch on fire. Right, exactly. Without it, the batteries are incredibly prone to catching fire. And you cannot simply, reroute your supply chain to replace 70% of the global market. You just can't.
Right. There's just not enough cobalt anywhere else to make up for that.
Exactly. So the DRC has the ultimate leverage to force the market to capitulate to their processing rules.
Okay, so they hold all the cards in that specific game. But what about a country that doesn't have a near monopoly like that?
And that is where the risk becomes really acute.
Yeah.
Emerging jurisdictions, countries that are just beginning to map and develop their mining sectors, like Malawi with certain rare earth elements, they face a much more precarious situation.
Because they don't have the leverage yet.
Right. If they impose strict export bans too early, before they have the domestic infrastructure, the energy grids, or the skilled labor to actually process the ore, they risk completely chilling the market.
They might just scare everyone away.
Exactly. They might scare off the initial exploration capital they desperately need to get the industry off the ground in the first place.
So it's basically a high-stakes game of geopolitical poker. And how hard you can bluff depends entirely on the unique periodic table buried under your specific borders.
That's a great analogy. And that reality brings us to how the major global superpowers are playing the board.
Right, because they're definitely not sitting this out.
No, they're heavily involved. Now, I do want to explicitly state here that we are impartially reporting these geopolitical maneuvers straight from the source texts. We're not endorsing the political strategies of the US, China, or any other government, but simply examining how these global superpowers are competing for access.
Absolutely. We're just looking at the data from a supply chain perspective.
Exactly. So, setting aside any political ideologies, we are seeing intense maneuvering for access. Currently, the landscape of critical mineral refining is extraordinarily centralized.
Yeah, the 2026 data shows some pretty wild numbers on that front.
It really does. It shows that China currently controls roughly 70% of global critical mineral refining capacity.
70% of the refining. Meaning, even if the rock is dug up somewhere else entirely, it almost certainly has to be shipped to China to be turned into a usable industrial chemical.
Yes. And it gets even more concentrated downstream from there.
Really? How so?
Well, when you look at permanent magnets, which are the essential components inside wind turbines, EV motors, advanced defense guidance systems, China controls up to 94% of global production.
94%. I mean, that is a virtual bottleneck on the entire future of clean energy and advanced hardware.
It is a massive choke point.
So how is the rest of the world responding to that 94% bottleneck? Because I see in the reports that the U.S., under the Trump administration in this 2025-2026 window, is pushing a strategy that analysts are calling minerals for security diplomacy.
Right. The U.S. strategy is highly focused on establishing physical, hard-coded supply corridors to break that centralization.
Okay, so building actual physical routes.
Yes. A prime example highlighted in the geopolitical texts is the signing of the Washington Accords with the DRC, combined with immense financial backing for something called the Libido Corridor.
Let's unpack the Libido Corridor, because it looks like a massive infrastructure play in these notes.
It really is. It is an 800-mile railway project. It's designed to link the absolute richest mineral regions of the Democratic Republic of Congo and the Zambian copper belt directly to the Atlantic coast in Angola.
So literally laying down the tracks to move the metal.
Exactly. The strategic objective is totally clear. Physically lay the steel tracks that will direct these critical minerals westward, creating an alternative logistics route that bypasses traditional choke points and aligns with Western supply chains.
But this minerals for security push isn't happening in a vacuum, right? And it's definitely facing some heavy friction on the ground.
Oh, a lot of friction.
Because there's this fascinating legal pushback, detailed in the notes. We're seeing a clash between two concepts, managed desperation and sovereign negotiation.
Yeah.
Like in early 2026, a coalition of Congolese lawyers actually filed a formal constitutional challenge against those very Washington Accords we just talked about.
And the legal argument they are making is profound. They are fundamentally challenging the validity of long-term resource contracts that are signed while a country is under extreme duress.
Right.
In the case of the DRC, they are pointing to the ongoing M23 rebel crisis in the eastern provinces.
So they're saying the timing makes it coercive.
Exactly. The lawyers are arguing that trading away a century's worth of geological inheritance while operating in survival mode is a form of managed desperation.
Wow. Managed desperation.
Right. And they're arguing it shouldn't be legally binding if it basically strips the country of its future economic sovereignty.
They're essentially saying, like, you cornered us in a burning building and asked us to sign away the deed to our house for a glass of water. And that is not a valid contract.
That captures the sentiment perfectly. And this is really where that second concept, sovereign negotiation, is taking over.
How does that look in practice?
Well, across the continent, legal teams and mining ministries are fundamentally changing the order of operations. Historically, a foreign mining company would secure the rights, build the mine, extract the rock, and then maybe, decades later, promise to discuss building a refinery.
A promise that often gets forgotten, I'm sure.
Exactly. But now, African governments are demanding that beneficiation, which is the strict requirement for local processing, smelting, and refining, be written into the foundational licenses before a single shovel hits the dirt.
Before the capital even hits the ground.
Yes, before the capital is deployed.
Okay, so the desire is fiercely there. The export bans and the new legal frameworks are the stick that's forcing the issue. But let's look at the actual physics and economics of this.
Because it's one thing to make a law, it's another to build a factory.
Exactly. Because slamming a vault door over your raw dirt is just policy. Building the heavy industry to actually process that dirt, the smelters, the chemical refineries, the kilns, that requires an entirely different reality.
It really does. It is arguably one of the most capital-intensive and energy-demanding transitions a modern economy can even attempt.
It's just massive.
And the structural bottlenecks preventing local processing right now are severe. They primarily come down to two things: power and money.
Let's start with power, because that's fascinating. The smelting of minerals is essentially applied physics, right?
It is. Take refining raw bauxite into aluminum, for instance. You rely on something called the Hall-Héroult process.
Okay, what does that involve?
It requires passing massive continuous currents of direct current electricity through molten cryolite. It is so ridiculously energy intensive that aluminum is sometimes jokingly referred to in the industry as solid electricity.
Solid electricity, that's wild. And the margins on that process are razor thin, right?
Very thin.
The analysts point out that for an aluminum smelter to be globally competitive on the open market, they need their electricity cost to sit somewhere below 4 cents per kilowatt hour.
Yeah, 4 cents is basically the threshold for viability. But when we look at the industrial reality across many African jurisdictions right now, Industrial power tariffs often sit well above 10 cents per kilowatt hour.
So right away, you're paying more than double for the absolute core ingredient of the refining process. You're already losing.
And it gets worse. That 10 cents often doesn't even account for grid instability.
Oh, right, blackouts.
Yeah, if your power grid experiences a sudden blackout or rolling load shedding, the molten metal inside those massive smelting pots can actually freeze solid.
Oh my God, what happens then?
If that happens, the multi-million-dollar pots are physically destroyed. You have to literally dynamite the frozen metal out of them.
You have to dynamite it out. That is a disaster.
Total disaster. So because of that risk, smelters are forced to build their own entirely redundant power grids, like massive backup diesel generators or huge private solar farms, which obviously drives the true cost of their energy even higher.
Right, because you're basically paying for 2 power plants. So it makes isolated, single-country heavy industry mathematically impossible.
Pretty much.
And that's just the power side of the bottleneck.
Yeah.
Let's look at the money side, because building a refinery takes years, sometimes a decade of construction, before you sell a single ounce of refined metal.
And that requires massive long-term loans.
Exactly. But the sources show that sovereign borrowing costs the interest rates these nations are charged when they issue bonds in the global market are 3 to 5 times higher for African countries than they are for OECD countries in Europe or North America.
Yeah, this is a crippling structural tax. Analysts in the reports call it the African risk premium.
3 to 5 times higher.
Right. So even if an engineering firm designs a brilliantly efficient, highly profitable copper refinery in Zambia, by the time you apply a 15% interest rate on the billion-dollar construction loan, the project becomes completely unbankable.
It's dead on arrival.
Exactly. The debt servicing eats all the projected profits before the foundation is even poured.
So we have a massive tension here. I mean, you've banned the export of raw rock to force local industry, but you can't afford the electricity to refine it, and the global markets are charging you punitive interest rates to build the factories.
It's a real catch-22.
Yeah. So how do you avoid just grinding your own mining sector to a complete halt?
And this is where we see a monumental shift in strategic thinking in the 2026 data. The realization is that hyper-nationalism, every single country trying to do everything entirely on its own will just fail.
They can't do alone.
Right. If we connect this to the bigger picture, the solution lies in continental integration.
Okay.
The key phrase you see in all these policy documents is regional value chains. And this is being driven by the African Continental Free Trade Area, or the AFCFTA, and cemented by agreements like the 2026 Magaliesburg Communique.
So basically breaking down the borders to build a single assembly line across the continent.
Precisely. They are acknowledging that no single nation, not even one as large and resource-rich as Nigeria or South Africa, has the perfect mix of cheap power, deep capital markets, and raw geology to build an entire supply chain from a raw mine straight through to a finished microchip.
But regionally, all those pieces do exist.
Exactly. Regionally, the pieces are all there.
So how does a regional value chain actually map out in the real world? Like, give me a concrete example.
Sure. Imagine it as a synchronized industrial relay race. You might have the raw lithium and cobalt extraction happening in the DRC or Mali, where the geology is just super rich.
Right, where the rocks are.
Right. But instead of putting that raw ore on a ship straight to Shanghai, it moves via new rail corridors to a specialized refining hub in, say, Ghana or South Africa, where they have aggregated the massive industrial energy capacity needed.
Oh, see.
And then from there, the processed battery precursors or the refined metals are shipped to downstream manufacturing and assembly hubs in places like Egypt or Morocco. Because they have the deep water ports and the highly specialized labor pools to integrate those refined metals into final consumer electronics.
Oh, okay. So you specialize based on your comparative advantage, right? Just like the aerospace industry does in Europe. Parts from Germany, engines from the UK, and it's all assembled in France.
That's a perfect comparison.
And the AFCFTA, the free trade area, is the legal framework trying to make that happen. The sources really highlight Wamkeli Mene, the Secretary General of the AFCFTA, and Ghanaian President John Mahama's Accra Reset Initiative.
Right. Mahama is the one setting this aggressive 2030 deadline to cease raw exports.
Yeah, he's really pushing it.
Yeah.
But Mohammed points out that even with all this political will, there is a massive, highly bureaucratic hurdle just completely choking this regional trade. And it's the currencies.
Yeah. The currency fragmentation across the continent is perhaps the most hidden yet most destructive tax on intra-African trade.
That's wild.
It is. Africa currently operates with 42 different currencies.
42. Okay, let's walk through what that actually means for a business trying to participate in this new regional value chain. Say I own a mid-sized factory in Accra, Ghana, and I need to buy a shipment of refined copper wire from a supplier in Nairobi, Kenya.
Okay.
I have Ghanaian cedis, they want Kenyan shillings. Under the traditional system, I can't just wire them the money directly.
No, you absolutely cannot. You are forced into the correspondent banking system.
How does that work?
Well, you would take your Ghanaian cedis to your local bank. That bank would then have to convert your cedis into a global reserve currency, typically US dollars or euros, using a correspondent bank located in New York or London.
Okay, so it goes to New York.
Right. Then that US dollar amount is sent to the Kenyan bank's correspondent account, where it is converted a second time into Kenyan shillings.
That is insane. So my money has to leave the continent entirely, travel to New York, get converted twice, and then travel all the way back to East Africa.
Yes. And at every single step of that incredibly long journey, someone is taking a cut.
Of course they are.
You lose money on the initial exchange rate spread to dollars. You pay a SWIFT transfer fee. The correspondent bank in New York takes a processing fee.
It just keeps shrinking.
And then you lose money again on the dollar-to-shilling exchange rate spread on the other side. Plus, it can take days to clear, and it bleeds an enormous amount of liquidity out of the transaction.
It is a spectacularly leaky bucket. I mean, you are trying to build an integrated industrial block, but the basic plumbing is siphoning off your capital to third parties completely outside the continent.
Exactly. Which is why the implementation of PayPSS, the Pan-African Payment and Settlement System, is treated as an absolute watershed moment in these 2026 financial reports.
PPS. Okay, what does that do?
PPSS is designed to completely bypass the New York and London correspondent banks for intra-African trade. It essentially acts as a digital continental clearinghouse.
So how does my copper wire transaction work under PPSS then?
So you go to your bank in Accra and initiate the payment in cedis, just like before. But this time, your bank pings the PAPS network. PAPS instantaneously calculates the direct CD to shilling exchange rate, validates the transaction, and instructs the Kenyan bank to credit the supplier in shillings.
Without converting it to dollars.
Right, without the dollar step. The actual settlement happens behind the scenes between the respective central banks, and they just net out the differences at the end of the day. The transaction takes seconds, and the capital never leaves the continent.
Wow. So it completely plugs the holes in the bucket.
Exactly.
And Wankilemeni's argument in these reports is that by eliminating those third-party friction costs and delays, PAPSS effectively unlocks roughly $800 billion in underutilized domestic capital.
That's a staggering figure.
$800 billion. And that is exactly the pool of money they need to start fixing the continent's $150 billion annual infrastructure gap. They are financing their own industrialization by just making their money more efficient.
It really is the financial prerequisite for hardware autonomy. You know, you cannot control your supply chains if you do not control the rails that your money moves on.
That makes perfect sense.
Yeah.
Okay, so we're laying the policy groundwork here. We're legally forcing local processing. We're fixing the payment systems to actually allow for regional trade. But here is the stark reality. Permitting, financing, and actually building new mines and massive new refineries takes a decade.
At least a decade, yes.
So we need a bridge to get there. Which leads us to a section of the research that frankly reads like a science fiction novel to me, but it's apparently happening right now in Southern Africa.
It's pretty amazing stuff.
Yeah, they have figured out a genius shortcut to secure critical minerals without digging a single new hole in the earth.
You are referring to the rise of unconventional extraction technologies, specifically these new initiatives to mine industrial waste.
Yes, mining waste. Let's talk about the Phalaborwa Rare Earths project in South Africa. The U.S. International Development Finance Corporation, the DFC, injected $50 million into this specific site.
Which is a huge vote of confidence.
Exactly. And when you look at the site plans for this place, there is no mine shaft. There are no massive tunnel boring machines anywhere. Instead, they are extracting high-value rare earth elements, specifically neodymium, praseodymium, and dysprosium, out of 35 million tons of phosphogypsum.
Which is the polite chemical term for what is essentially a sprawling, decades-old landscape of toxic waste left over from a decommissioned fertilizer plant.
Literally giant toxic waste dunes. They are mining garbage. But the engineering logic here is just brilliant.
It really is.
Because in traditional hard rock mining, the single most energy-intensive, expensive step is the crushing and milling of the rock. You have to blast the mountain, load the boulders into massive diesel trucks, and grind them down into fine dust before you can even begin the chemical extraction.
It takes an unbelievable amount of diesel and electricity.
Right. But at Phalaborwa, that phosphogypsum waste was already crushed, milled, and chemically cracked decades ago by the fertilizer operation. The hardest mechanical work is literally already done.
The energy savings there are just astronomical. And because the energetic barrier is so much lower, they are actually designing the new extraction facility to operate on up to 90% renewable energy.
That's incredible.
They are basically taking an environmental disaster zone, actively cleaning it up, and simultaneously extracting the exact high-specification minerals required to build F-35 fighter jets, nuclear submarine navigation systems, and offshore wind turbines.
It's an incredible two-for-one deal. Clean up the waste, get the minerals, and we see the exact same philosophy at the Monte Muambi project over in Mozambique, which is backed by a nearly $1.9 million grant from the U.S. Trade and Development Agency.
Right.
They're applying new extraction techniques over there to focus on gallium, which is the absolute linchpin for 5G network towers and EV power electronics, along with high-grade fluorspar. But let me pause here for a second, because I was reading a Reuters market analysis in our stack, and it points out a really fascinating irony. Rare earths aren't actually rare.
No, they're really not. That is correct. From a purely geological standpoint, the elements themselves are relatively abundant across the Earth's crust. Honestly, you probably have trace amounts of rare earths in the soil of your own backyard.
Right. So if this stuff is literally everywhere, why are these specific projects in South Africa and Mozambique causing such a global stir? I mean, why the $50 million injections from the U.S. government if it's just dirt?
It comes down to the nightmare of separation.
Okay, what does that mean?
While rare earths are abundant, finding them in concentrated veins is highly unusual, but the real problem is chemical. In the Earth, rare earth elements are almost always geologically bound together with radioactive elements, specifically uranium and thorium.
Wait, so meaning when you dig them up, you are also digging up low-level nuclear waste?
Exactly. The traditional methods used to break those chemical bonds and separate the rare earths from the radioactive host rock are incredibly toxic, environmentally devastating, and really dangerous to the workers.
Oh.
You end up with these massive lakes of radioactive acidic slurry. That is exactly why so many Western nations outsourced this processing to other countries decades ago. They simply didn't want the environmental liability in their own backyards.
It was an environmental shell game. Just push the pollution somewhere else.
Exactly. But the Phalaborwa project is revolutionary because of the specific chemistry of that phosphogypsum waste. It is naturally very low in radioactive thorium and uranium.
Because the fertilizer process didn't use it.
Right. So by processing this specific waste stream, they completely bypass the radioactive toxic nightmare of traditional hard rock rare earth mining. They are proving to the global market that Africa can offer a cleaner, highly concentrated ESG-compliant alternative.
And ESG meaning environmental, social, and governance compliant.
Yes. And in 2026, when every major tech and auto company has aggressive carbon neutral and clean supply chain pledges that they have to meet, a clean source of neodymium isn't just nice to have, it commands a massive strategic premium.
That makes total sense. It's not just having the mineral, it's having the clean mineral. That shifts the entire value proposition for these companies. Okay, so we've mapped out the physical materials now. We are securing clean neodymium from waste dunes. We are refining lithium regionally through CFTA corridors. We are moving the capital seamlessly via PPSS.
We've got the foundation built.
Right. Now, we reach the real inflection point.
Right.
How does a continent make the leap from just supplying the processed materials for the microchips to actually making the microchips themselves? We are talking about the minerals to microchips roadmap.
And this is really where the narrative shifts from the physical geology of the Earth to pure intellectual property.
Brains of the operation.
Exactly. As of the data entering 2026, the African continent captured less than 1% of the global semiconductor economic output. It was virtually a non-player in the silicon space.
Basically zero.
But the landscape is undergoing a rapid transformation, and it's driven heavily by the explosion of fabless semiconductor design hubs across the continent.
Okay, let's define fabless for a second for the listeners. That means these companies design the complex architecture of the microchip, like the billions of microscopic transistors and the actual electrical pathways. But they outsource the physical manufacturing, the actual printing of the chip, to a massive foundry, usually in Taiwan or South Korea.
Precisely. And this is a highly strategic, very calculated entry point.
Why not just build a factory?
Well, if an African nation tried to instantly compete in physical manufacturing by building a cutting-edge, front-end fabrication plant, a fab, it would require an upfront capital investment of $20 to $30 billion.
Oh, wow. Yeah, that's steep.
Not to mention you need a hyper-purified water supply and an absolutely flawless energy grid. Attempting that on day one would be economically catastrophic. So instead, they are capturing the high-margin intellectual layers of the value chain, the design, and the architecture.
Let's look at the companies actually executing this because the reports highlight some fascinating players. A huge standout in the 2026 data is a deep tech startup called ChipMango, based in Lagos, Nigeria.
Yeah, ChipMango is a perfect example.
This company was founded by former systems architects who used to design chips for Tesla and major Silicon Valley firms. They came back to Lagos and set up a $10 million design center. And their model is brilliant.
It really is. They utilize a proprietary AI-powered upskilling platform to rapidly train local Nigerian software and electrical engineers in advanced chip architecture.
So they're building the talent pool from scratch.
Exactly. And once trained, those engineers provide global, world-class chip design services to the international market.
And the economic disruption of their model is pretty severe. Because of their geographic location and their AI-accelerated training pipeline, ChipMango is able to offer top-tier semiconductor design services at a 60 to 80% cost discount compared to engineering teams based in California or even establish hubs in India.
Which is an insane competitive advantage.
It is. Yet, because the baseline operating costs in Lagos are structured differently, the company is still achieving massive 70% gross margins.
Wow.
They are proving that you can turn local human capital into a globally competitive, high-margin technological export.
It's pure brain power exportation. But, it's not just about doing it cheaper, it's about doing it securely.
Ah, right.
And this leads us to another really fascinating company highlighted in our stack, Neelix Chip Design, operating out of Ghana.
What are they doing differently?
Well, they aren't just designing generic processors. They are heavily focused on something the industry calls a hardware root of trust.
A hardware root of trust. Okay, unpack that.
This is perhaps the most vital component of technological sovereignty. Neelix is embedding security directly into the physical silicon itself, utilizing technology known as physical unclonable functions, or PUFs.
Wait, I need to understand this. Putting security inside the physical silicon? I always think of security as software, passwords, encryption keys, firewalls. How do you physically manufacture security into a chip? What exactly is a physical unclonable function?
Think of it like a human fingerprint, but for silicon. When a semiconductor foundry bakes a silicon wafer, the manufacturing process is incredibly precise, but it is never utterly perfect at the subatomic level.
There's always some variation.
Right. There are always infinitesimal, microscopic variations in the thickness of the silicon or the exact placement of atoms along the electrical pathways. It's kind of like blowing glass. No two pieces, even from the exact same mold, have the exact same microscopic bubbles or ripples.
Okay, so every single microchip, even if they're the exact same model, off the exact same assembly line, has unique, random physical imperfections.
Exactly. A physical unclonable function leverages those exact random imperfections.
Oh.
When you apply a specific electrical voltage to the chip, which they call a challenge, the electrical current travels through those uniquely imperfect microscopic pathways and produces a slightly different voltage output, the response.
Oh, I see.
Because those atomic pathways are completely random and physically unique to that single piece of silicon, it is physically impossible to clone it.
That is mind-blowing.
The chip generates its own unique cryptographic key based purely on its physical structure, and that key isn't stored in any software memory that a hacker could access.
The manufacturing flaws actually become the ultimate password.
Exactly.
And Neelix in Ghana is designing this architecture, which makes sense, because if you are an African government rolling out a new digital ID system for 50 million citizens, you don't want to buy off-the-shelf microchips from a foreign superpower because you can never be entirely certain that the hardware hasn't been compromised or backdoored at the factory level.
Right, you just don't know.
But by designing the root of trust domestically, Neelix is ensuring that the foundational bedrock of the continent's digital infrastructure is entirely sovereign.
It completely eliminates the paranoia of the black box. And beyond the sovereignty aspect, there is a massive argument for global resilience here, too. The reports heavily reference the 2026 helium crisis as a sort of cautionary tale for why this is needed.
Ah, yes, the helium crisis. For context, in early 2026, geopolitical conflicts in the Gulf caused the global supply of helium to choke. And helium is absolutely essential in semiconductor manufacturing. It's used to cool the silicon ingots and purge the chemical chambers.
You can't make chips without it.
Right. So when the supply lines choked, the price of helium doubled overnight, and it nearly brought the entire centralized global chip supply chain to a grinding halt.
It really exposed the extreme fragility of having the entire world's advanced technology dependent on a handful of hyper-centralized hubs.
It's terrifying how fragile it is.
It is. So having distributed design centers in places like Legos and Accra and expanding into back-end assembly facilities, what the industry calls OSAT, or outsourced semiconductor assembly and test in regions like Morocco and Egypt, it creates a much more resilient global ecosystem. It diversifies the intellectual and physical choke points.
Design and assembly are massive leaps forward, definitely. But let's be honest, actual physical manufacturing, like the actual printing of the wafers, the building of the equipment that makes the chips, that is the ultimate holy grail.
Absolutely.
And that brings us to what might be the most visually striking moment in this entire stack of 2026 data. We are traveling to East Africa's Silicon Savannah.
We are looking at the launch event that took place at Dedan Kimathi University of Technology, known as DAKUT, in Kenya.
Okay.
This was the unveiling by a company called Semiconductor Technologies Limited, or STL, and they launched something called the Ol Borana system.
The Ol Borana system.
Yeah.
I was absolutely geeking out over the engineering specs in the notes for this.
It's an incredible piece of machinery.
It is. This is the very first advanced semiconductor manufacturing system that was designed, engineered, and entirely built in Kenya. It is described as a thin-film silicon wafer sputtering system that uses precision robotics to process nanomaterials.
A mouthful, I know.
Yeah. Now, I understand precision robotics. But for my sake, and for anyone listening who doesn't have a PhD in material science, what exactly is sputtering? How does this machine actually work?
It is a highly advanced physical vapor deposition process. To visualize it, imagine a microscopic game of atomic billiards played inside a vacuum chamber.
Atomic billiards. I like that. I can picture that.
So inside the Ol Borana machine, you have a vacuum chamber containing a target material, let's say a specific ultra-pure metal like titanium or aluminum.
Okay.
You also introduce an inert gas, usually argon, into the chamber. You then apply a massive electrical field, which turns that argon gas into a glowing, highly energized plasma.
So you have a glowing cloud of gas hovering over your piece of metal.
Yes. And because of the electrical charge, the argon ions, the cue balls in our billiards analogy, are violently accelerated into the target metal.
Whack!
Whack. When they slam into the metal, the kinetic impact physically knocks individual metal atoms right off the surface.
Oh, wow.
Those liberated metal atoms fly across the vacuum chamber and embed themselves onto the surface of a blank silicon wafer, creating an unbelievably thin, perfectly uniform film that is literally only a few atoms thick.
That is wild. It's basically subatomic spray painting using a plasma cannon.
That is a very accurate, if slightly dramatic, description. But yeah, that ultra-thin film is the foundational canvas upon which the microscopic circuits of the microchip are eventually etched. Without sputtering, modern semiconductors simply do not exist.
And a team of engineers in Kenya built the machine that does this. They built the plasma cannon.
It did.
Now, the sources do clarify that the Ol Borana system is currently geared toward pilot production, research, and development, rather than churning out, millions of commercial chips a day. But the symbolic and strategic value of this is just off the charts.
It represents the breaking of a massive psychological and technical barrier. African engineers are no longer just theorizing about high tech, and they are no longer just writing software for devices built elsewhere.
They're building the hardware.
They are physically manufacturing the machines that manufacture the future. They are building the tools to build the tools.
But a machine like Ol Borana is incredibly complex. You can't just build it and then hope you find someone who knows how to operate it. You need an entirely new class of highly specialized technicians.
Which is exactly why the hardware launch was coupled with a massive educational initiative detailed in the reports, known as OPVET.
OPVET, what's that?
This is a continent-wide overhaul of technical and vocational training backed by heavy investments from the European Union and the CSIR in South Africa.
Oh, nice.
The explicit goal of OPVE is to graduate thousands of highly specialized field engineers, the people who actually know how to calibrate a vacuum chamber, handle energized plasma, and repair a magnetron sputtering system.
So they're building the workforce at the same time.
It is the rapid construction of the human infrastructure required to support the new hardware infrastructure.
Okay, let's step back for a second and just look at the trajectory we've mapped out here. You start by locking down your critical minerals and enforcing local refining. You fix the currency pipelines to trade those refined metals regionally.
Right.
You begin designing sovereign security architectures into the silicon, and you start building the physical machines that process the wafers. We are moving up the pyramid of technological evolution rapidly. So what sits at the very top of that pyramid? What is the ultimate goal of having your own minerals, your own chips, and your own power?
The apex of the pyramid is owning your own intelligence, which brings us to the final major paradigm shift in the 2026 data: the intersection of hardware and artificial intelligence.
The big one.
Yes. We are looking at the race for sovereign AI and data independence.
Because the demand for AI in the global south is just exploding. The reports project it as $1 trillion market materializing almost overnight. We're talking about AI models optimizing agricultural yields in drought conditions, analyzing hyperlocal financial data to issue microloans, diagnosing diseases in rural clinics.
The demand is practically infinite.
It really is. But there is a massive structural flaw in how this is currently operating, isn't there?
Yes, there is a severe risk of replicating the exact same extraction dynamic we saw earlier with raw minerals, but this time with data.
How so?
The current model relies heavily on sending all that highly valuable, hyperlocal African data to massive, centralized hyperscale data centers located in the global north in the US, Europe, or China.
Okay.
The data is processed by foreign-owned AI models, and then the resulting algorithmic insights are sold back to the continent at a premium.
Oh, I see. It's the lopsided supply chain all over again, the wheat and the bread. Only instead of digging up cobalt, you're digging up human data. You export the raw data for free, and you pay a huge subscription fee to import the intelligence generated from it.
Precisely. The intellectual and economic value of that intelligence bleeds outward. And to sever that dependency, the 2026 reports highlight a landmark multi-billion-dollar partnership between three key players.
Who are they?
Amini, which is a rapidly growing African sovereign AI infrastructure company, Foxconn, the world's largest electronics contract manufacturer, and Bull, the French leader in high-performance supercomputing.
That is a heavyweight alliance. What's their goal?
Their stated objective is the rapid deployment of sovereign AI infrastructure directly on the continent.
And the specific technology they are deploying to achieve this is what the notes call modular AI data centers. Now, hold on a second. Let's apply some critical logic here based on what we discussed earlier.
Sure, let's hear it.
When I picture an AI data center, I picture a sprawling, multi-acre concrete fortress operated by Amazon or Google, consuming a gigawatt of electricity and requiring millions of gallons of purified water every day just to keep the server racks from melting.
That is the standard model, yes.
But we spent 20 minutes earlier establishing that many industrial grids in this region struggle to supply stable power to an aluminum smelter. How on earth do you drop a hyperscale AI factory into an environment with severe grid instability and high power costs? The physics just don't seem to add up.
And that is exactly why it's a brilliant engineering pivot. You do not build a monolithic, gigawatt-consuming facility. You build modularly, and you engineer the hardware to adapt to the reality of the environment.
Okay, so what does a modular data center actually look like?
A modular AI data center is essentially a highly dense, self-contained supercomputer built inside a standardized, weatherproof shipping container.
So it's basically a supercomputer in a box.
Yes, exactly. And because it is modular, you completely avoid the massive, multi-year, billion-dollar upfront capital expenditure of pouring concrete for a traditional facility.
Oh, so you can start small.
Right. You deploy one module, which might only require a few megawatts of power. As local demand for AI compute grows, you simply truck in another module and plug it into the network. You scale horizontally, like snapping together Lego bricks rather than trying to build a massive tower all at once.
That makes sense financially. But that still doesn't solve the power grid flickering off. If you were training a massive language model and the grid drops for 5 seconds, don't you lose all your compute progress?
Not with this architecture. These modular units are designed with advanced power gating technologies and massive integrated lithium-ion battery buffers.
Built-in batteries.
They act like giant, uninterruptible power supplies. If the local grid experiences a sudden voltage drop or a rolling blackout, the servers don't crash. The intelligent power management system instantaneously shifts the compute load to the internal battery buffers, gracefully riding out the grid fluctuation without interrupting the AI training cycles.
That is incredibly smart. What about the cooling?
Well, instead of relying on massive, water-guzzling HVAC chillers, these modules often use advanced liquid cooling directly integrated into the server blades, which is vastly more efficient and doesn't require millions of gallons of municipal water.
So they are completely ruggedized for the reality of the infrastructure. They are resilient by design.
Exactly.
And the payoff for solving that engineering challenge is absolute sovereignty. By keeping the physical server racks local, it means that an African telecom operator or a regional bank or a national healthcare system can train their AI models on their own local data, and that data never crosses an international border.
It stays entirely within their control.
It never enters a foreign jurisdiction where it could be subject to surveillance or intellectual property theft. They completely escape the dependency on foreign hyperscalers.
It perfectly closes the loop of hardware autonomy. From the physical abstraction of the rare earth elements required for the servers, to the localized processing of the microchips, to the final generation of sovereign artificial intelligence, the entire vertical stack of the future economy is brought within the strategic control of the continent.
It is a breathtaking transformation, and the speed at which it is happening in this 2026 window is just staggering. Let's just pull back for a second and recap the massive ground we've covered in this deep dive.
It's been a lot.
We started with the sheer audacity of over 10 nations slamming a vault door shut on 30% of the world's raw critical minerals. We look at the economic realities of smelting and how the continent is stitching together 42 fragmented currencies with a unified digital payment system to bypass the global banking choke points and unlock $800 billion in domestic capital.
Which was the key to funding all of this.
Exactly. We explored the genius of environmental remediation, literally pulling F-35 fighter jet minerals out of decades-old toxic waste dunes to bypass the radioactive nightmares of traditional mining. We traveled to the Silicon Savannah to see Kenyan engineers firing plasma cannons to build advanced semiconductor machines. And we finished by unpacking how modular, battery-buffered AI factories are securing the final frontier of data independence.
It is a systemic, highly calculated realignment. We are observing a continent actively rewriting its role in the global order. They are moving decisively from being a passive, historically exploited supplier of raw ingredients to becoming an active, sovereign architect at the highest echelons of technological innovation.
And I want to leave you with a final, provocative thought to mull over. We've spent this entire time talking about macroeconomics, geopolitical supply chains, and complex engineering. But think about your own daily life. Think about the smartphone sitting on your desk right now or the electric vehicle you are thinking about buying next year.
Yeah, bring it down to the personal level.
For your entire life, the absolute pinnacle of technological innovation has been synonymous with a handful of very specific places: Silicon Valley in California, Shenzhen in China, Taipei in Taiwan. You have been conditioned to believe that the future is only ever invented there.
But the data from 2026 strongly suggests a different trajectory. Imagine a very near future where the most resilient, hyper-efficient new AI architecture or the next massive leap in green energy storage isn't born in a sterile lab in California. Imagine it is fundamentally optimized for and forged within the harsh, variable, and rapidly growing environments of the global south.
Exactly. It is highly probable that in the next few years, you will turn over your next high-tech device, and the intellectual property, the absolute genius inside the machine, not just the raw cobalt in the battery, might proudly carry a new stamp. Designed and assembled in Africa, from the locked vault of the red earth to the sovereign silicon brain of the future. Thank you for joining us on this deep dive. Keep questioning the systems around you and keep exploring these shifting global fault lines. We'll see you next time.